All right, good evening, folks. It's Mick Cullen here, and you'll be joining us on a webinar for the CH47 Chinook. We're sitting here with Tyson. So, Tyson, thanks for being able to join us.
Yeah, thanks for asking me to be here.
All right, folks, just before we kick off, it's just important that we know that you guys can actually hear us and you can see the screen. So, you should see some floating webinar control panels there at your end, and you'll be able to find a little hand icon. So, if you can press that, that'll put your hand up at our end. We can see that goes up. You also have a chat box. So if you want to type a quick question, you can just let us know that you see the screen. That's some great feedback for us, and then we can kick on with that. So you can use the chat box. Okay, so I've got a couple of hands there. Great, guys. I'm going to actually just go through and put your hands down and just checking through the questions. And this is a bit of a problem. Oops. Perfect. Yep. Okay. So a couple of questions through there. A couple of comedians as well. So nice work, guys. Okay. So we're recording this, and let's crack back up. What we'll do is we'll stop occasionally for questions to go through. But as you get a question, just drop them in the in the question box there, and I've just got to break the slides to get through and look at those. So we'll stop and take questions as we go through. And Tyson will pretty much crack in now and start going on. So,
Okay, well,
back up in there.
Yeah, thanks again for asking me to be here. Talk about the Chinook. It was my all-time favourite helicopter to fly. Obviously, it's quite a big, powerful machine, and I was very privileged to fly it for about 4 years while I was with the army, and it was the last machine that I actually got to fly while I was in the army. So it was a good note to finish up on before jumping in the mighty 22. So
yeah, let's have to do some comparisons as we go through. But
you're not wrong, yeah.
Okay, excellent. Let's you ready to crack into it?
Yeah, why not?
All right, so let's go.
All right, so basically we're going to talk about the history. Now, I will admit that I didn't know a lot about the history before we started putting this webinar together. So I've just jotted down some facts about the history. Now, most of this you guys will be able to find on Wikipedia. So, but I'll just run through a few bits and pieces. So the first model, the Chinook, was actually it was a Vertol, and it gained its name as a CH47 Alpha in 1962, and they had a grand total of 349 of those machines built. Most of them saw service or went straight to Vietnam, and so they were quite valuable to enhance the Iroquois lift capability, or the troop lift, as well as the deployment of larger stores around the battlefield. I've got the 4 ACH47 Alphas. Now, these were known as Guns a Go-Go. Now, this was an experimental unit that was raised, and basically it was 4 CH47s that were designed with guns situated all around them. They had rocket pods and miniguns. They had 40mm cannons on the side, and it was pretty much just a flying arsenal, pretty much like the Apache is now, but obviously it was quite a big, or it would have been quite a horrific sight seeing one of those coming straight for you. Now, 3 of those crashed in combat, and one of those is still around today, and that's actually at a museum near Fort Rucker in Alabama. So it's still there. So if you're ever in the States, you can go and have a look at that.
Do you talk about your training as we go through, and the fact you actually went across to Fort Rucker?
Yeah, I'll do that. When we finish this history stuff, I'll go back and talk about the training, because that was quite a good course to be on. So the Guns a Go-Go, that was an experiment. It wasn't very successful. They lost 3 out of the 4. So then they saw the requirement to enhance the actual machine itself. So they increased the size of the engines as a temporary fix to before they came out with the C model. So the B models were actually an interim fix while they were developing a bigger and better C model. And then once the C came out, it not only had the upgraded engines, but it had a lot of other nice little mod cons that made the machine A, easier to fly, and B, more powerful.
And the actual airframe, like to look at it from the outside, was been pretty standard from model to model.
Yeah, it has. It's changed very little. Between the B and the C, they changed the aft pylon slightly, but generally the main frame they got right pretty much first go. So,
Nice. Okay.
yeah. So a bit more on the history. Yeah, we'll go to the next slide there. Oh, sorry, just go back one. Sorry. Yeah, and the C with the upgraded engines, the C model was able to lift 46,000 pounds. That's total gross weight.
Was it the biggest helicopter in the world at the time, or was there still?
I'm not entirely sure. I am not sure when the Mi-26 came out, but yeah, it was certainly one of the bigger lifting capabilities around at the time. So the D model. Now the D model is the one that I got to fly. Australia has the D model. So it was first introduced in 1979, and basically it was such a great machine that they decided that they would return all the A, B, and C models and switch them over to Ds. So as you see there, 472 in total were converted to Ds. So we'll go on. I'll talk about the D model a little bit more. And as for the F model, which is now the current machine, although there are G models in production or in theory at the moment. But the F model is the one that Australian Army is hopefully getting in 2016. Now the difference between the D and the F, apart from there's 200 or so fewer parts in an F model, it also has a nice glass cockpit. So we've got computerized instruments, which obviously give a much nicer readings to the aircrew while they're operating the machine.
And just on the Australian ones, they sat in mothball for a while, didn't they, at Ambley?
That's right.
They went across and got transferred over or upgraded, or
so they did. We had the older models. They were sitting in mothballs post Vietnam, and we sent them over to the States. We sent over 10, and we got back 6, and they came back as nice shiny D models. So the original stamp for the frame was still on, and they came back with that original stamp. So the manufacture date of the frame, but then they came back as D models.
Okay.
So I've just got there, best to Google the details for the latest model, because obviously I didn't get to fly the Fs, and I've only really seen them in photos and that sort of thing. So, all right, so there she is. So as you can see there, the shape's pretty much the standard shape that you'll see throughout all the models of the Chinook. So the tandem rotor. So obviously in a conventional helicopter, you've got your main rotor, which turns, and you've got your tail rotor, which is your anti-torque. Now they had to think about this and thought, how can we get more disc area to create more lift? So they put a second main rotor to the rear of the machine. Now the aft rotor spins in the opposite direction as the main rotor. In an American design system, which these are, the forward, well, they're all American design, the Chinooks. The forward rotor spins the conventional way, so it spins anti-clockwise, and the aft rotor spins in a clockwise direction. Now, most people think, now, do they actually spin at different RPM, and is that how you turn? No, that's not exactly right. The rotors are totally in sync. So where one blade will pass across the center cowling, then the other two, then the front blade will pass over the center cowling, then the aft blade. So it's they work
basically intermeshed. Okay,
yeah, basically. So and that's why you see there they actually overlap in that bottom right picture. Now the masts themselves, the pylons, you can see they're forward and aft. The front rotor system on the front pylon has actually got a tilt on the blades of 12 degrees, and the aft rotor system has a tilt forward of 9 degrees. Now this is designed so that when the aircraft is on the ground, it's got a natural tendency to want to taxi forward, and being on wheels, you don't have to use any power, and you just release the brakes and you can taxi the aircraft around.
Does it help level altitude and flight as well, so you're not so much nose down?
Absolutely. So having the disc tilt, so we naturally want to fly forward as well, and the disc tilt helps in leveling off the aircraft.
Yeah.
So with the maneuvering the aircraft from, say, from on the ground, pick it up into the hover, she sits quite nose high at the time. Now, if we were to push forward the cyclic in a conventional helicopter, obviously it tilts the disc, and the airframe follows the disc underneath. In the Chinook, it's a little bit different. So as we push forward on the cyclic, instead of tilting the discs, now the aft disc will actually gain more thrust.
Okay, so your pitch is increasing more, or as you're pushing forward on the cyclic, you're actually increasing your pitch on the rear blade.
Exactly.
Yep.
And you don't reduce it on the front because you don't want the nose to sink, but the front will follow, depending on how much input you put in, along with your thrust lever, which in a conventional helicopter is called the collective. Now, because we're changing the amount of thrust on the forward and aft blades, the collective lever, or as you would know, the collective is known as the thrust lever in the Chinook.
Now, I've been in a jump seat once, so where your collective lever would normally come back to a pivot point sort of at the rear and pivot on the back of the collective, from my memory, is basically it just went almost straight up and down.
Exactly. Yep. So it comes out of the floor. So basically, you're pulling the thrust lever straight up out of the floor. It's quite unique when you first see it, but it feels exactly like a conventional helicopter to fly, except you've got 100 foot from tip to tip, so it makes it a little bit different. So, and obviously you've got pedals as well.
Yes, I was going to ask about the ground steering and the pedals and the wheels. So the rear wheel's caster?
Yep, so there's the rear wheel's actually caster. One of them is a hydraulically driven wheel. So as you maneuver the pedals on the ground while you're taxiing forward, it'll hydraulically steer the aft right wheel, and that's how you steer while you're on.
And the other one just follows.
The other one just follows around like a standard caster. In forward flight with the pedals, they actually act a little bit different to. Obviously, we've got no tail rotor to affect. So picture the helicopter just in a standard hover, and in a normal helicopter, you'd put in left pedal, you'd increase the pitch on the tail rotor, and you'd make a turnabout the mast to the left. Well, in the Chinook, if you're in a standard hover and you put in left pedal, then the forward disc will tilt to the left and the aft disc will tilt to the right. And the whole machine will pivot around the central point.
Okay.
So basically, that's the main difference between the conventional helicopter and the tandem rotor. Obviously, we've got a much larger disc area because we've got two main discs, and they can produce a lot more thrust.
You see your G range must be massive as well.
Absolutely, yeah, because we've got the whole thing's designed to maximise the internal load. So you can see there the width of the rotors across the whole machine makes it quite versatile for CFG changes.
Okay. And we've got one question there from Dave. Yeah. No worries, Dave. Thanks for joining us late. It's no hassles at all.
G'day, Dave.
All right, ready for the next slide then, Tice?
Yep, absolutely. All right, well, there's a picture of me. So that's what I looked like when I was about 10 kilos lighter. So this is me doing my pre-flight on the left engine while I was in Afghanistan. So the engines themselves, we had the T-55 GA 712 engines at the time when I was in Afghanistan. So these are the original engines that were on the D model. So they are over 4,000 shaft horsepower, one on each side, and they provide a massive amount of power through the transmission systems and up to the main rotor. So you can see there on the front there, the cone type thing. Now that's a rough screen filter for the air intake, and you can see various hoses and alike just below the engine. So a couple of those hoses are for, we've got hydraulics, we've got engine oil, we've got fuel, and a few other air lines to help the engine perform at its best. But I've got their 2 plus engines, or 2 engines plus. The other engine that I'm talking about there is the auxiliary power unit, which is a smaller engine. It's pretty much the size of a Jet Ranger engine. And basically that sits in the aft pylon right at the back. I think we might have a photo.
I'll see if we can pull this other diagram while you're chatting.
So we've got this photo here of a breakdown.
And just zoom in.
So you can see we've got the 2 main engines, and then up the back there you see the number 100. Now that there is the 3rd engine in the Chinook. So that's the auxiliary power unit, and what that does, it's its own turbine engine, and it provides the power to run the hydraulically operated starters for the main engines. So we need a fair bit of power.
So your start process then would be, so you hop in, do your pre-flight checks.
That's right.
You're going to start up your APU.
Start the APU.
And it's obviously like starting a Jet Ranger, as you said. So you have this Jet Ranger running in the background, and then using the power off that engine to get the other 2, or using the air, I guess, or driving the hydraulics to get the other 2 engines to spin up to be able to start the rest of the helicopter.
Yes. So we don't start both the main engines at the same time. We only ever start one at a time. But the power that's generated from the auxiliary power unit is enough to turn the get the start sequence started on the main engines. While the APU is running, we can raise and lower the ramp. Provides hydraulics to other systems as well, and we can go through our control checks. And before we start the main engines, we can check all our hydraulic flight control systems running off the APU. So
do you remember the fuel burn on the main engines? Like, what's your
yes? Well, I've got that coming up. You're getting ahead of me.
All right, sorry.
Yeah, so I've got all those details coming up. So we'll talk about that a little bit more in detail.
Sure.
Okay, so we can probably skip to the next slide. All right, so there's our the schematic we were just looking at. Now, this machine has got 5 transmissions. So normally in a conventional helicopter, you might have 2, so your main transmission and your tail rotor transmission. The Chinook's got 5. So if we skip over to the next slide, there we go. So we'll talk from the front. So we've got the forward transmission, comes directly off the forward, underneath the forward mast. And it basically comes down, and all that does is turn the rotor, the drive system 90 degrees, heading back to the combination transmission, which is number 79. I think you can make that out as a 79.
See if I can get you a cursor on there. I can't at the moment. But yeah, so the back is the middle circle there.
Yeah, so that's your combining transmission. Now you'll see the 2 circles on the in front of the engines. Okay, that's your engine transmissions, left and right engine transmission. And so basically that takes the raw power from the engine, and that turns that 90 degrees back into the mixing or the combining transmission. We've also got the aft transmission, which is connected to the mixing transition via another shaft. So the combination of all 5, 4 of them are connected to the combining transition, which has a lot of smoke and mirrors in there to make.
So it must be a pretty crazy setup.
It is. It's and these things are, a person wouldn't be able to lift these transmissions. They are that big. Maybe the engine ones you might be able to handle yourself, but the in particular the combining and the aft transmission are just massive bits of machinery. So it's really quite impressive. Now, obviously, they're especially the forward one, I used to notice a lot, sitting right above the pilots there. It's actually right above the companionway, which is in between the two pilots there. There's a little jump seat. Now, if you're ever sitting in the jump seat, which Mick, I think you said you have, that's actually one of the noisiest parts of the helicopter right there, because you're sitting right below the forward transmission, and you haven't got much separation or soundproofing in there. So that's yeah, it's really quite a noisy system. But having 5 transmissions is really quite unique, and obviously all their temperatures and pressures need to be monitored the same as any other transmission would. So, yeah. All right, so here we go with some of the interesting stuff here. So to operate the machine, it says in the flight manual it's a minimum of 3 crew. So obviously we've got the aircraft captain and a co-pilot. In the Australian Army, they're both trained to the same standard. Everyone's trained to as the aircraft captain. All right, the stats. Oh, sorry, the other crewman is an engineer. Or in the Australian Army, we had air crewman techs who were tradesmen who were also trained as load masters. So they would operate they would sit on the ramp at the back of the aircraft, and they'd have a number of gauges that they had to monitor, pressure and temperature gauges, as well as operate the ramp.
Okay. So that just frees you guys up for a little bit then, as far as monitoring some of those.
Exactly, yeah. And generally, if you have any minor maintenance issues that arise, they're trained to the level where they can just fix them on the spot, and we keep the machine moving. So as you can see there, the length nearly 100 foot long, so it's quite a big machine. Now that is tip to tip, so it's it's not the actual fuselage itself. The rotor diameter is the one that gets me, so a 60-foot rotor diameter. Now, for those of you who do know a bit about flying already, you'd know that the ground effect is determined by not only your airspeed, but also how close you are to the ground and your rotor diameter. So having a 60-foot rotor diameter provides a lot of ground effect for you.
And I don't know if you talk about the downwash, but I mean, the downwash is incredible. I remember seeing them come in and there'd be gum trees on the side of the oval, like a big gum tree.
Absolutely.
And seeing a gum tree bent in half.
Yep.
Under the downwash of the Chinook comes over the top of it and then spring back up. And you just could not believe the trunk that big could bend
definitely
like that.
Well, that was part of our training, was the awareness of your downwash, because it was just so massive. And especially if you were getting fully loaded, like you can see there, our max gross weight was 50,000 pounds. If you were operating up near those max gross weights, your downwash is just immense. So you've got all that thrust just coming down and has to go somewhere. I've seen, when I was going through my officer training at Duntroon, I actually saw a whole grandstand get blown over by a Chinook that was coming in to do joy flights for us. So it's really quite amazing. So now, here's an interesting fact. The fuel load, 6,600 pounds. That's maximum capacity. Now, there's 6 fuel tanks on the Chinook, and that's the big bulgy things down each side of the aircraft. They're your fuel tanks. Putting them on the outside there obviously frees up all that space internally, so we can get all the cargo and that sort of thing in there. So basically, a basic empty weight was 26,000 pounds or thereabouts. When we took ours to Afghanistan, we put in ballistic protection on the floor and on the sides up to sort of waist height, and our basic takeoff weight was 32,000 pounds.
Yeah, okay.
So we had 18,000 to spare for our cargo. Now you can see there, that's a photo I took of just one of our standard loads. We had some people sitting towards the back. That was their gear. We're taking them up to a forward operating base, and some miscellaneous, what looks is probably coffee and other types of rations and stores and that, going out to one of the forward operating bases.
Okay. Now you could also carry, we'll grab Dave's question in a moment. You could carry internal fuel blizzards. Could they be plumbed into the rest of the fuel system?
That's right. I've got that. I think it's the next slide. We can. I know you're very, very good at.
Oh, can you hot start the APU? I think Dave, you're talking about can you cook it?
Well, actually, the APU, it was the Solar. I think it's the T62T. I can't remember the specifics of the APU, but it's basically a button start. Well, it's a switch start. So it was basically a case of flicking the switch forward. Now, why they don't put that technology into helicopters, so it does it all for you.
Black Hawk's the same. It's basically APU on off, and
Yeah.
as you're waiting for it to start up and the lights to come out, you basically hold your hand right in front of the T handle for the fire switch for that. So I don't know if it's the same.
It was exactly the same. So it was basically flick a switch and the APU would turn on. And while we're flying, we wouldn't have the APU on. As soon as the main engines are started, then that's when we flick the flick the APU off. So it was basically just one of those on-off switches, which would be good if you had that for every other type of helicopter. You wouldn't get those hot starts. So good question though. Okay, we might just go to the next slide. Okay, so some of the interesting stuff here. So the VNE is 170 knots, but generally we used to cruise around the 130, 120 to 140 knot range. Now, each Chinook had its own personality. As anyone who's flown an aircraft would understand, each one's got their own personality. Some aircraft, my favourite was 104. What number is that? That's 201 in that picture there. You can see on the dash. As you accelerated, get up towards that 130, 140, 150 mark, then each machine would get its own distinct vibration. And that was her telling you just to back it off a little bit. And obviously, depending on your on how heavy you were on the day, you'll get the vibration earlier. So she would tell you when you were going too fast, and basically you ease it back from there. Fuel burn, so 2,400 pounds per hour. Now that's both engines, so which made it quite easy. 1,200 pounds an hour. So that's when you're doing your fuel calculations based on your time, it made it quite easy. And that was what we'd plan at. Often, especially if we're light, you wouldn't use anywhere near that. You'd probably base it on 2,000 pounds per hour.
Sure.
Now I've got there the ERFs, that extended range fuel system. Now that was a series of 3 bladder style tanks that you could insert up the middle of the Chinook, and we used to do a thing we called fat cow operations. So basically, we could be a flying fuel truck. We would fly out to forward operating bases or a position out on the ground. We would set up our own a number of refueling hoses coming out the back of the machine, and then we could have Black Hawks, Apaches, other machines, other Chinooks come and refuel off the back of our extended fuel tanks.
And could you burn that yourself? Like, is it plumb into your own?
Yes, absolutely. So we could just plumb it and keep flying. So the machine could stay airborne for 8 hours. I think it's 8 or 9 hours or something like that. So it was really quite an amazing setup. Just because they can lift so much, they can carry so much.
In that picture, I'm just noticing, and you probably can't see it at home on the webinar, but it's got Vertol written on the top of the pedal there. So yeah. That's reference to the original.
To the original design was the Vertol. So I haven't noticed that before until you just pointed that out, Nick. So well done.
There you go. I saw the angle.
So you can see in that photo there, that's one of the guys. We used to get a lot of kids or friends and families say, "Oh, can you take this and get a photo in Afghanistan while you're flying?" So one of our guys, it was one of his children's bear. So we got that photo. Now in that photo, you can see just next to the bear there, that's the caution panel, the main caution panel. So this photo was taken during a startup procedure. So as you go through different stages of startup, different lights would start to go out, and basically you don't take off until all the lights are out. Yeah.
It looks pretty standard. Like, if you take away the flight instruments,
absolutely,
and you've got a few radio boxes, so if you're sitting in it, it looks like a normal helicopter.
Absolutely,
cockpit.
Yep. So the standard 6-pack of flight instruments. Now you see most of the gauges above the bear's head are just duplicates, and that's just for each engine. So it's just basically running, keeping an eye on 2 engines instead of 1. And the new F models, I believe, have all the computer generated images and that will start flashing at you if you're exceeding a limit. And yeah, it makes life really nice and simple for you. So
Excellent. Okay.
yeah. All right, so there's that's 104. That's I'm flying in the right hand seat of that photo there. So that's coming back from Tarankout to Kandahar in that machine. Now the Australian Army Chinooks, when we deployed to Afghanistan, we got fitted out with a minigun, and that's what you can see on that side there. The minigun, it's a 7.62 millimeter minigun. Basically, it's a 6-barreled machine that will it'll shoot out 3,000 rounds per minute. So each barrel is knocking out about 500 rounds per minute. Because it's such a low rate of fire per barrel, that's why you can get a high rate of fire, because there's 6 of them.
It doesn't overheat.
Yeah. So initially we had problems with the amount of brass that was falling overboard. That it was getting jammed back into the door that you can see there. So our guys came up with the dump tube idea there, and it effectively took all the extra of the brass that and the linkage for all the rounds, and just dumped them conveniently overboard.
Below the aircraft, yeah.
Say again?
Below the aircraft,
yeah. Below the aircraft in a way. So you can see just below the engine there at the back, we had our own a missile warning system, and it would automatically deploy flares so that if there was any surface-to-air missiles that were coming for us, the flares would spit out. They would burn hotter than the engine and attract any heat-seeking missiles away from the engines in the aircraft.
Yeah, the big cutout in front of the aft pylon there.
Yes,
that's just purely for cooling air.
Yeah, that's air. That's in the big air intake, and it goes through and it gets circled around to just to cool basically all the transmissions systems through the aft pylon.
Okay, and again, a traditional helicopter's got like your tail fin and that sort of area at the back, and that's the aerodynamic sort of shape there on the aft pylon.
Yeah,
that helps a little bit as far as keeping it straight.
It does. As you can imagine, in forward flight, it sort of cuts through the air pretty well. However, it does have its disadvantage. If you're in a crosswind hover, so you're getting the wind from one side, or actually like just one big sail.
Yeah.
So where you'd think such a big, strong, powerful machine can hover quite easily out of wind. It's not the case, because we've got such a large surface area. You do get buffered around quite a bit on the crosswind hover. So, all right, so there's my ugly mug again. So this is in Kandahar. You can see there. So that's a Mag 58 machine gun, 7.62 millimeter machine gun. Oh, sorry, 5.56 the Mag 58. Sitting on the aft ramp. So that's the ramp in the down position. You can see there's two other. You can see just to my right there on the other side of the gun. You can see another little part of a ramp that folds down, so we can drive cars and wheel pallets and that sort of thing up onto the rollers.
So could you fit like a normal civilian car in there, or is this for little Jeeps? Or
no, you could drive. Yeah, you could drive a Commodore straight in the back of one of those. So there is quite a bit of room. Obviously, the seats have to be folded right up out of the way, and we've got the roller system set up in there. That can be removed quite easily. The main reason we have that is because when we deliver stores and that to guys out in the forward operating bases, generally it's on pallets, ammunition, food, and all that. It's all palletized, so it can just roll straight in and straight out. So it's obviously more efficient for us to deliver. You can see there I've got the wearing the Air Warrior vest. That was the equipment designed by the Americans, which we bought off the shelf from them, and that basically has first aid kits, satellite radio, but most of all, lots of ammunition, and you can see the handle of my pistol, which would just sit in front of me, and basically that stuff was there for if for whatever reason we found ourselves on the ground, we had a bit of protection, and we could patch ourselves up if we needed to, and call for help.
Yeah.
So yeah, well, quite well set up there. So we'll just run through a few photos here just so I can kind of give you an idea of what it was like. This is an interesting group of pictures. We were on a job. We were taking this this container. It's called a mill van. It's like a
like an ISO container on
wheels,
wheels,
basically, yeah. And it's permanently on wheels. So we're taking that up there, and we didn't know what was in it. We just had to take it to Tarancow. And now, if you look in the top left picture, you can see the mill van hanging underneath. If you look at the forward set of straps, just before they go up and connect onto the forward hook, you can see the strap is actually crossed over. Now, what's happened that during the hookup crew inadvertently crossed the cables over, or it was twisted when they put it up. So as we were flying along, the machine would swing back and forward. Sorry, the mill van would swing back and forward, and eventually it gave way. So the second picture there, as you can see, the hook. Oh, sorry, the strap's still hanging off the front, but it's not hanging off the rear at all. That's because when the front one broke, our load master did what he was trained to do, released the load, and it fell away to the ground, which is the bottom left picture. That was all that was left of it. And you can see the broken strap there.
Did you find out what was in it?
It turned out to be it was office furniture. So it was lucky. We had an Apache with us. He stayed on site while we went off until we found out what it was. Office furniture. Okay, we can let them have that.
All right.
So, yeah. And everyone gets a flat tire from time to time. You can see off to the right there, you can see the guy's hand on the jack. And yeah, basically you just got to jack it up and replace the tire just like you would your any other car.
All right, and Toss, I'm just going to one question here. What's the biggest thing you've ever fitted in the back?
Oh, in the back. Well, probably the heaviest thing that we've had in the back was ammunition. We did a mission where we had to do a resupply of some artillery pieces in the Helmand province during a major offensive over in Afghanistan, and basically we had we were up to our max all-up weight with pallets of 155 millimeter artillery shells. Yeah, so they were that was all up. That was the heaviest load we ever did. But as far as physical space, you could see in one of the earlier photos of the loading, we would often fill up the back to its max capacity, but
still have weight left to go. Yeah, so you'd bulk out with you run out of space rather than be weight limited.
Yeah. So, but underneath, well, the hook system, the way it works, well, there's 3 hooks on the Chinook. We've got the forward, middle, and aft. So the middle hook, if we go, there we go. So you can see in this photo up the top left, we're hooked up on the forward and aft hook. So the middle hook can actually carry 26,000 pounds. Oh yeah, you can see them there. Okay, so the middle hook can carry 26,000 pounds on its own, which is, that's 12 ton. That's amazing. The forward and aft hooks can carry 17,000 pounds on their own. However, if they're used in tandem, it's a maximum of 25,000 pounds.
Yep.
So when I was on my basic course at Fort Rucker, we part of our training was to go and do what they called the big block, which was a 12-ton block, just one big block of concrete.
Yep.
And we would go and pick that up and go and do a circuit and fly it back in and drop it off where we picked it up from.
Now, the unique thing too, you can carry 3 separate loads. You can carry like an individual load under each.
Absolutely.
Each hook.
On each hook, you can, provided that you don't exceed your max takeoff weight.
Yep.
Or any of the individual hook loading.
You put them on different strops. So the first one will be the shortest, then the last one will be the longest, or
yeah. But basically, it depends on the aerodynamic load.
Yeah.
The load masters will work out how something's going to fly, and they'll work out the most appropriate way to do it.
All right, Dave's got another question here.
Okay, will the aircraft still fly on one engine if the other fails? Excellent question. We spent hours and hours and hours in the flight simulator practicing what we call OEI, one engine inoperative. Now the Chinook, because it had those such powerful engines, yes, it can fly on one engine in forward flight, and sometimes, depending on your all-up weight, it can even hover on one engine. So basically, it's the same as most other twin-engine helicopters. They're designed to load share, and so if you do lose one, the other engine will pick up the load of the failed engine.
And this is where the transmissions get freaky because all that power for the engines are going into the transmissions, and it obviously can take one and both, or any combination.
Yeah.
Now, if again in 22 or something like that, we come in for we do our practice, our limited power training sessions. We come in and we do like a running landing.
Yep.
What's the running landing look like in a Chinook?
Oh, it's pretty good fun actually. Basically, the first thing we're going to do, I always remember back to this, we've got to lock in the back wheels. So the back wheels are casters basically. So we've got what was called swivel switches, which would lock in the back wheels to keep them.
Oh, it's like a shopping trolley as you come.
Yeah, basically. Yeah. And the last thing you want is to touch down with your wheels going all wonky and that sort of thing. So we lock in the wheels and then basically fly an approach like an aeroplane. If you're on one engine, you didn't have the power to hover, so you want to keep that forward airspeed on and touch down with the aft wheels first. The aircraft will slow. You just hold it into the flare, and then once you're on the ground, then you slowly lower the nose. And that was pretty much how we did our dust landing approach as well.
Yep.
So basically, we'd bring the aircraft low, keep the forward airspeed on, so our rotor wash was behind us, so we still had visibility. We'd touch the aft wheels down and then rotate the nose forward.
And the dust cloud catches up with you and rolls forward.
And totally enveloped you. So yeah, it was quite exciting. We're nearly there, guys. I'll just run through a couple more photos here. That's me again. I've put this photo in so you can see the day HUD, or the head-up display, and I managed to sneak my little camera up and try and take the best photo I could of what we're actually seeing through the day HUD. So you can see it's a little green image that I'm basically looking straight through. You can see your normal horizon, all that outside. However, there is an artificial horizon in the middle. On the you've got down the bottom, you can see a little balance ball there, so that tells you I was flying a little bit out of balance, but not too bad. On the left-hand side in the middle, you've got 93A and 113G. So that's my airspeed and my ground speed. So airspeed's obviously straight through the pitot system, and my ground speed, that information is coming from our GPS. Above those two, you can vaguely see some numbers, and it says T1 and T2. So that's the temperature of the engines, and just basically so we can keep an eye on the how hard we're working the engines. And below the 93 and the 113, we can see 59 and 67, and so that's the torque that we were pulling, or how much torque we were producing on each engine as we were flying along. On the right-hand side there, you can see 116. That's our RADALT, so radar altimeter. So that's how far in feet that we are off the ground. So that used to vary. Generally, on the flat country, we used to fly about 50 feet.
Yep. Between
50 and 100, and where at night time we'd raise that up to 100 to 200 feet.
And what elevations were you at? So Tarankout was how high above sea level?
Tarankout was about 3,000 feet.
Yep.
And the highest one I landed at was 8,800 feet.
Okay, and what sort of DAs were you getting? Do you remember?
Oh, well above that. So yeah. we were landing, and it was still 27, 28 degrees up at 8,000 feet, okay. Which is really quite intense. We actually went to Papua New Guinea to do some training up in the high country there, to just to prepare ourselves for landing in the high density altitude areas. Okay, oh, there we go. I've thrown this photo in there for two reasons. A, I love the Adelaide Crows, and B, just to show you a bit better look at the minigun there. So you can see we have one minigun on each side, and then we had the ramp gun. So the minigun was quite a valuable asset to have. It just, you felt a little bit safer when you're flying along with one of those.
Now, what did you think the first time that thing fired while you were flying?
Well,
How did that sound?
I'll tell you what, the first time I heard it firing in Afghanistan, I had just landed in country. I was brand new, and I was sitting in the back. We were getting a ride back from Taran Kowt down to Kandahar, and they test fire the minigun. We used to test fire on every flight. So here I am, brand new in country, and all of a sudden they're starting to shoot out the side. And I thought we were under attack, and it was, yeah.
Oh, I remember in the Huey, the first time you hear the door gun go off. But then the other one that really caught me by surprise was the 50 cal sniper rifle.
Absolutely.
That thing,
It's insane.
You think the engine's falling out of the aircraft.
Absolutely, yeah. So the minigun was quite good, and as you can see, just in that photo there, we've got you can see where it says strike face, just in the cockpit there. That's some ballistic protection that we had for the aircrew on the front. Obviously, you can't do it right at the front of the aircraft because you still have to see through your chin bubble to land. So they give you as much protection as they can without impeding the performance. Yeah.
So two questions there. Dave's asking about the Blackhawks. I think he's talking about the HUD display, and yeah, it's the same symbology, the same display, and you could rotate through different modes. So you might have like a night mode or a day mode. I never flew with the day HUD. It's just basically the night HUD, so it's basically a ring that would go on the end of the MBGs. So yeah, I never got to do the day HUD. It hadn't come in, but yeah, otherwise same numbers, same display. And Cameron's got the question there about operating at high elevations that handle different.
Oh, absolutely. Now, the Chinook being such a big and heavy aircraft, the difference between operating at sea level to operating, as we say, HDA, high density altitude, the machine is less responsive primarily. And so you basically have to treat everything like a limited performance approach. So nice and slow, and thinking well ahead of your escape plans if you need to go around because things aren't looking good. But absolutely, yeah, she while she'll still perform well because it's such a great machine, it can feel a bit sluggish compared to operating down at the lower levels.
Yeah, I mean, when we do our training, whether it's 22 or whatever, we do limited power training. So one, if you're hot here on the ground and carrying lots, or if you're up on top of the hill, counts for that as well.
And so, yeah, basically that goes for all aircraft in high density altitude areas.
Yeah. But excellent question. Yeah, it's good.
All right. This is so we can have another look at the cockpit. But photo on the left there was the donut shop which I had on Kandahar base. We would, if we were going out in particular to visit the Australian SAS guys, we would always make sure that we went and bought some donuts.
Their favourite.
Well, it's look after your own guys in particular. They used to love donuts and ice. If they could get ice while they're out there, they'd think that was great. But if we would fly 7-8 hour missions in a day and come in and land at one of the forward operating bases. If we know we're going to be back there in half an hour's time, we'd ask them to organise some food. And what you could see there would, you'd probably send it back if you got it in most prisons. But that's the kind of grub that was served up to us while we were.
I mean, the funny thing I'm thinking here is, you got peas, trying to eat peas in a helicopter cockpit is just ridiculous.
Yeah, I'm pretty sure it wasn't the highest bidder that put that meal together. So, but so there you go. We're just eating on the run while we're working. So there you go. That's one of my favourite photos. That one. The sunsets at Kandahar were quite spectacular because we get the orange glaze in the sky. But,
well, most of your photos there, I've seen clear shots, but most of those shots you've got have got haze or dust or something in it.
Yeah, absolutely.
So the flying conditions over there, was it more hazy than not, or was it a mix of days?
No, definitely. It was generally quite hazy and
Is
get
it
a
just
lot
because
of
there's a
dust devils.
lot of fires in the villages, or is it more
No,
just the dust?
yeah, generally it was the dust. You had while it was a large rocky area, there was you'd go extensive expanses of land where it would just be dust and sand and get a bit of wind or just the temperature of the day would generate local effects.
Little whirlies.
Yeah,
Yeah.
we dust devils everywhere. You could go from through the main Kalop Valley, and at any one time you'd be looking at 7 or 8 dust devils through the valley. So and they'd go up to sort of 700-800 meters high. So it was they were quite impressive. So
Yeah, the thrust lever. So if let's back up. So quick question there about what's the right of the
there you go.
P's.
Yep.
So yeah, depending on what you can see, that's the thrust lever Tyson was talking about. So in a normal helicopter, you had the collective would go all the way back. This went back, what about 5, or maybe only about 4 inches, and then it just cut off.
It was basically a handle, and underneath the handle there was basically sunk straight down into the floor, and that's our thrust lever. It operated exactly the same as the collective, but they called it the thrust lever.
Does it move aft, fore and aft, as well as vertically? No, it was basically straight up and down.
No,
Wasn't
it was,
yeah.
just basically pulling it out of the floor and then pushing it down again. So, it was really quite amazing.
So keep throwing questions in, guys. We've got a couple of minutes there to answer questions. Dave's asking about maintenance routine. So what was the maintenance routine like in Afghanistan compared to Australia?
Well, we had our tradesmen, excellent tradesmen. I can't speak highly enough of how good they were. We'd have 2 shifts. So they were working on a 12-hour roster. So we'd have a full crew of maintenance guys on duty at any one time. Now, basically, they would keep the standard ongoing maintenance happening, so the forecast scheduled maintenance. And if we did have any issues, then they would beg, borrow, and steal. One time we had a engine transmission hot light come on, which means they had to replace the engine transmission, and they got that done in a kind of under 6 hours or something like that.
You had 3 airframes in country?
No, only ever 2.
2, okay.
We did on occasion rotate one out, so we had the new one in place before the old one would leave. So we only had 2 primarily to work on at any one time, but they the guys were right on top of the maintenance schedule and just working all the time. Because we were surrounded by the Americans, we didn't have to have a lot of our own specific equipment like cranes to lift engines in and out and to take the mast or rotor system off. We just borrow that sort of thing off the Americans, and they were more than happy to help us.
Yeah. You want to talk about the Fort Rucker?
Okay, Fort Rucker was the main flying training base in the States. It's actually got 4 airfields on the military base itself, and they train Apaches, they train Kiowas or OH-58s, they trained Chinooks, and they also train Black Hawks there.
So the flying program, it must be staggered, and you take off from the main field, go out to the satellite fields, do your bits and pieces, and come back.
Yes.
It must have been a swarm of helicopters just appear over the.
Most of the satellite fields would have their own hangars and all that, and that's where. So for me, I had to drive maybe 12 kilometres down to my airfield.
Yep.
And then that's where I was doing my training from. So, but it was all classes the same base of Fort Rucker. So my course was 3 months in Fort Rucker, and that took us from this is a Chinook right through to here's a certificate, and from there we went up to Seattle in northwestern America, and we did our Australian standardization with our own instructors in the American sim over there.
Yep.
And that was 1 more month, and from there we covered all the emergencies, but we did our instrument rating. So went through and flew all the different types of approaches and instrument flying.
And all the tactical stuff, did you do that at Fort Rucker as well? Or
Yes.
Did you do that? Okay.
Yes. So primarily we did all our low flying training.
Yep.
There. The tactical specific stuff, we developed a lot of our own before we went over there. and then we were embedded with an American company, and we worked together on our own procedures.
Sure. Yeah. All right, so a couple of quick questions here. I'm just going to cherry pick some of them though. This is a great one. The daily. How long before a flight would you have to get out there to sort it all
out? Basically before any mission that we had to do, we would leave the camp 4 hours before. So we'd drive from our accommodation block down 4 hours before. Now, mind you, this is in Afghanistan, so we had a lot of extra planning and that sort of thing. But the daily itself, basically, it'd take you about, on your own, it'd probably take you 45 minutes. But generally, we used to break it down into 3 areas.
Yep.
So there'd be inside, up the top, and outside. Outside on the ground, inside the machine, and then up the top. So, basically, we'd try and split it up amongst the crew. If you were there and you were there early, then you'd just start doing it all. But the thing is, there was some screwdrivers. You needed a screwdriver to actually do the pre-flight. So you'd be having to unscrew cowls and that to open them up and check things out. And the screwdrivers were actually a part of your startup checks. You had to make sure that all 3 screwdrivers
were back in
their appropriate place. So, but the daily, it was, it did take a while. It was, it was really quite interesting, and there's always stuff to look at on the Chinook. So, it never bothered me too much doing the daily.
Does anyone fall off the top?
Oh, I'm sure they have, but that's why they've made these beautiful big stands and ladders so they can just push up to the side of the machine and work on do the maintenance instead of people just trying to hold on to the side. Yeah, it's a long way up.
Okay, so we're getting on time, guys. So we'll crack through these, and then it's been awesome. You've stuck around, so obviously getting something from it. So, did you ever get shot at while you're over there?
We did actually, a couple of times. I probably had two main incidents. The biggest one of note, not for me though, was we did a major operation. I did the flight planning side of this particular operation, where we went in and dropped off some special forces guys to go in and do a seek and capture or kill mission. And basically they got into a big contact. It turned out it was the local Taliban Rotary meeting that night, and everyone happened to be there. And without divulging too much, it was the first time Australians had returned fire from a helicopter since Vietnam.
Yep.
So that was the 9th of July 2006. And there was quite a huge gunfight. Our supporting Apaches, actually, one of them had to return to base with a number of bullet holes in it. And but our Chinooks managed to get in and out with RPG fire and small arms fire all over them, and get out unscathed.
Yeah.
So there was certainly a lot going on. But a lot of the time, especially during the day, you wouldn't know if you're getting shot at with small arms fire. You might see an RPG, but even then, there was a case where we had some SBS reporters on board, and they were just reviewing some footage afterwards, and in their footage, they happened to catch an RPG just going past the back ramp. So if you could even Google search that and see the RPG flying past. So yeah.
And the last one that we'll answer tonight is from Campbell again. So I don't know. So he's asking about the best advice getting through BFTS and then a couple of abbreviations. So I'm not sure about the other ones if you recognise those. But so basic flying flight training school would be that BFTS one. And here in Australia, that's in Tamworth. So to come in as an Army pilot, you would go in through recruiting. You'd go down to Tamworth and do basically 6 months or about 120 hours in a little 2-seater aeroplane. And then you'd go back into doing the flying training in helicopters and go through that way. Now, BFTS is, there's more detail there. BFTS is pretty hard through Tamworth because it's tri-service, so you're Air Force, Navy, and Army. And we started with 9 guys on our course. And of those 9, 3 guys got through to the end game of flying training in helicopters and into the units. And that was a pretty average kind of scrub rate. It was definitely one of the hardest things I've done.
Oh, me too. Yeah. So the best advice I would give you is don't hang your hat on it. Just take every day as it comes. I thought every day was a bonus that I was there. I'd just make sure, I would take my time on the weekends to have time to myself, but I would try and prepare the best I could for each flight, and then try not to put too much pressure on myself. And that goes with anyone who's doing any type of flying training. Do your preparation. Get in there, try and learn as much as you can while you're doing the flight, but don't beat yourself up too much, because it's very hard. What we do is very hard. And especially when you're learning, we used to use the analogy, the fire hose is coming. And
yeah, just so much information being thrown at you.
Exactly. So, you open up your mouth, get the fire hose in there, and try and swallow all the information you can. So,
but like anything, like any skill or any topic, as you go along, you just, you pick it up, and one thing leads to the next, and after a little bit, it just happens, and you think back and thought, wow, I've never thought I'd be able to do this, and
absolutely.
So it's definitely doable, and it's just a matter of working hard at it. So, okay, look, we'll close that up then, guys. We'll leave it basically there as far as questions goes. And please, you can always jump over to the website at aeropowerflightschool.com.au, and I'll show you that in a moment, and send us your questions, either call up or send them in via email. But if you've been listening and you've been bitten by the flying bug, the next obvious step, if you're interested in that aspect, would then probably be to come in and have a look at a helicopter operation, and go talk to them in the hangar and have a look at the training machines. And then probably go for what we call a TIF, so a trial instructional flight, which, depending on where you go, with us at AirPower, it's about a 45-minute flight, and we're going to take you up with an instructor and essentially give you the controls and give you a chance to push and pull and see what all the different controls do, and then demo maybe a little bit of low flying or an auto rotation. So we come in and show you what would happen when we practice taking the engine back to idle in flight. And you basically get a hands-on chance of actually flying it yourself and seeing what it's all about. So that would be the next step. If you do head over to the website, and again, I'll just pull it up quickly now so at least you see it on the screen. So it's aeropowerflightschool.com.au. You'll find a section there about the trial introductory flight. You get that as a gift voucher, and you can purchase that online there. There's also, if you're on this webinar, you've probably already got the handbook and a few other things downloaded on our email database. But if not, you're watching this as a recording, then definitely on the website, there's a 198-page helicopter book with pretty much everything you need to know about it there, and a few other bits and pieces as far as resources go on the website. So look, thanks very much, folks. Really glad you can get along and get something out of that. And again, any questions, shoot them through, and we'll talk to you guys soon. So thanks, Tice.
No worries. Hope to see you guys soon.